Model Solutions, January 2019, paper 2HR. So the first question is to do with mean and the modal class. So let's take a look. The modal class is the class interval that has the highest frequency. So it's 12 less than D, which is less than or equal to 16. Okay, highest frequency. To work out an estimate for the mean, you need two additional columns. One is MP for midpoint, and the next one is midpoint times frequency. So if you struggle to work out the midpoint of two numbers, what you do is you add the two numbers together and then divide by 2. And it's nice to use the fraction button to do this as well. So write down your midpoints. You have 2, 6, 10, 14, 18. Multiply across, so 16 times 2 is 32, and so on. Total up the midpoint times frequency column. Total the frequency column, and sometimes they give you this information first sentence. Then divide the sum of the midpoint times frequency by the total frequency, which is 100, which gives us an answer of 10.68. You never ever round the mean, unless of course they ask you to, which is a bit bizarre, but you never round the mean. Next question. So what we need to do is we need to work out the volume of each of the toy bricks. Okay, so we can do that. The volume of a triangular prism, if you look at the formula sheet, it tells you to work out the area of the cross section and then multiply it by the length. So the area of the cross section is a triangle, so it's base times height divided by 2, and then multiply it by the length of the shape. So 6 times 6 is 36, divided by 2 is 18, 18 times 5 is 90 centimeters cubed. The cross section on this one is a semicircle which has a radius of 3. So it's the area of a circle is pi r squared. So it's pi times 3 squared, but also it's a semicircle, so we half it, and then we times it by the length of the shape, which is 5. Okay, if you type this into the calculator, you end up with an answer of 70.6858, etc. Question asks, how much greater is the volume of block A or toy A compared to B? So it's 90 minus 70.6858 blah blah blah, and we end up with an answer of 19.3 when you round it to one decimal place. But I always advise to copy down the calculator display and then to round it. Next question. Find an expression for the nth term. The sequence goes up in sixes, so the formula starts off 6n. The second part of the formula is what number comes before the first term. Well, if it goes up in sixes, count back 6 and you end up at 4, so it's 6n plus 4. The next question. There are numbers that are in both sequence S and sequence T. Find one of these numbers. Well, I know the formula to sequence S, and I know the formula to sequence T. So I can set the formulas equal to each other. So 6n plus 4 equals n squared minus 3. Rearrange this to give n squared minus 6n minus 7. So if I factorize this, I end up with n 7 1 minus 7 plus 1. So I get n equals 7 or n equals 1. Now, these are not the answer to the question. They just tell you which terms in the sequence are the same in both. So the first term and the 7th term. And it's the same in both sequences, so it doesn't really matter which one you substitute n into. So if we substitute n into this one, we've got 1 squared, which is 1. 1 minus 3 is minus 2. Find one of these numbers. I'll do another one just for fun. 7 squared minus 3. 7 squared is 49. 49 minus 3 is 46. Okay. You can write just one down, but that's my way of doing it. Next question. Jacob walked 10,800 steps. On Sunday, he walked 7% more steps than on Saturday. So, to increase a number by 7%, you multiply it by 1.07. Remember, the multiplier for increasing a number by a certain percentage is 1 plus x over 100. So 1 plus 7 over 100 is 1.07. And type that into calculator, 11,556. Okay, next question is bearings. So what I need to do here is have my equipment ready. Postbox is 140 meters from the library, so according to the scale, that will be 7 centimeters, and it's on a bearing of 220 degrees from the library. It says from the library, that's where you're going to place your attractor. So what we need to do is either go clockwise 180 degrees and then add on another 40 degrees to take us to 220, or you can go anti-clockwise 140 degrees, which is what I'm going to do. So let's line this up. It's pretty good. Okay, and mark on 140 degrees. The little dot there. So just as precisely as I can. Yep, that's great. So the dot is now correct. What I need to do now is now draw a line 7 centimeters long from the library, but in line with the dot. So in line with the dot. Yep, exactly 7 centimeters long. So let's just try and draw that. It's all about accuracy, this question. Okay. That's fine. Now, it says mark the position with cross and a P. That's fine. Use your scale drawing to find the real distance in meters of the hall from the post box. So again, use my ruler. Go from the hall to the post box. Okay, and I would say that's around about 7.6 centimeters. So 7.6 centimeters. Find the real distance. 7.6 multiplied by 20 meters, because every centimeter is 20 meters. So 7.6 times 20 gives us 152. Okay, the allowable range is 150 to 158. Next question, find the bearing of the hall from the post box. So when it says of the hall from the post box, this is the most important bit. This tells you where to start. We start from the post box, and we're going to go to the hall. So what we need to do, let's draw a line, goes from the hall to the post box, like this. And we also need to draw a north line at the post box. Okay, so because we're starting from the post box and we're going to the hall. Now, the question, bearings, always deals with north lines and going in a clockwise direction. So we start at the north line and we go in a clockwise direction to the hall. This is the angle that we're trying to work out. Okay, and what I'm actually going to do is work out the inside one here. I'm going to subtract it from 360. let's do that. Try and do this on here. Not so accurate on here, always. Okay. So I think I make that out to be about 28. Yeah, that's about 28 degrees. I do 360 minus 28 gives me an answer of 332. The mark scheme accepts 330 to 334. Next question. So we have pentagon drawn inside a regular octagon. Okay, so let's remind ourselves that in a pentagon, in any shape, the sum of the interior angles is given by this formula. So if you want to know what the angles add up to in a pentagon, do 5 minus 2 and then times it by 180. So if we do 5 minus 2 times 180, it's 3 times 180, you get 540 degrees. So it's 540 degrees inside pentagon. Now it tells us that the pentagon has exactly one line of symmetry, which will be down the middle here. So that means that this angle here will be the same as this one here. Okay, that's based on that sentence. So I can subtract these these three angles, from 540, and I can work out the base angles there. So 540 minus 2 times 112 minus 84 gives me 232. I can divide that by 2. 232 divided by 2 gives me 116. So each of these angles is 116 degrees. Okay, and I know it's not accurately drawn, but it does kind of look like 116 degrees. What about one of the interior angles of the regular octagon? When it's a regular octagon, all the angles are the same. So work out the interior angles using the same formula. 8 minus 2 times 180, which is 6 times 180, which is 1080. I can divide that by the number of interior angles, which is 8, because we know they're all the same. That gives us 135. So this angle here, in fact, all of these angles are 135. So if I want to know what x is, do 135, which is the red one, minus 116, because these x and 116 total together to give 135. Take 116 away from 135, we're 19 degrees, which is the answer. Right, so I need to work out the length of y, and I know that I can draw an additional line on this diagram, right here somewhere. Now, up to this line, it's 37. I just need to work out this extra bit here and then add it on to work out the value of y. So this forms a right angle. Now we do 125 minus 90, that gives me 35 there. And I can draw this triangle out separately, you see. I'm trying to work out the base of it. Let's call the base x. The top angle is 35, and I know that this is a length 15. So I can use trigonometry to work out x. Yep. Label the triangle. This is O, and this is the adjacent. So I'm going to use TOA, from SOHCAHTOA, TOA. If I fill in the triangle, T stands for tan, brackets the angle. So it's tan of 35 degrees. O is x, and the adjacent is 15. If you cover x, you realise you have to times tan 35 by 15. Do that, we end up with 10.5, etc. Okay. And then add that to 37 to work out y. Y is equal to 47.5 03, etc. And then round it to one decimal place, 47.5. Next one. So some simplification involved here. Okay, simplify fully. So what we do is we can type in the numbers in the calculator. 15 divided by 5, that cancels to 3. We have k to the power 4 divided by k to the power 1. When you divide, you subtract the powers. So it's k cubed, and then m cubed divided by m squared. When you divide, you subtract the powers. You can either write it as m to the power 1, or just m. Solving an inequality means to get x in the middle. So there's a minus 1 that we need to deal with first of all. So we add 1 to each section. We end up with 8 less than 4x, which is less than or equal to 18. Then we can get rid of the 4 by dividing by 4 because it's 4 times x. So we're going to divide every section by 4. When you do that, you end up with 2 is less than x, which is less than or equal to 4.5. This is the answer to the question. Okay, next question. So, compound interest. The formula for compound interest is you have your initial value times multiplier, which is 1 plus x over 100 to the power of the number of years. So Omar invests 6,000 dirhams. 6,000 multiplied by 1 plus 1.5 over 100 to the power of the number of years. So 4 years. Okay, let's type that in. 6,000 times bracket 1 plus 1.5. Oh my god. Over 100 close bracket power of 4. Okay, so 6,368.18. Okay, this is how much Omar will have in his account after 4 years. The question says, work out the total amount of interest Omar will have received. Just the interest, the free money that the bank gives you, which is always very nice. So work out the difference between what Omar started with and what he ends up with, and you can see that the difference is 300 and well, it's 368.18, but to the nearest dirham, it's 368. Next, so it's slightly harder, but still in the grade 5 territory. Power of half means to square root. Now, if you don't know this, of course, you can just type this into the calculator. 16 to the power of a half means to square root 16, which is 4. When you have a bracket to a power, you multiply the powers. So 8 times a half is 4. 6 times a half is 3. With this question, what we can do is we can make it into a single fraction, first of all, by finding a common denominator when we add or subtract. Now 2 and 3 both go into 6. So set this equal to 6. Okay, what we can do here is think, what do we times 3 by to end up 6? We times by 2, so you times the top by 2. 2 times 8 minus 2x minus. What do you times 2 by to end up with 6? You times by 3. So you times the top by 3, 3 brackets, 2x minus 3, and this is all equal to 4. Brackets are really good because you're less likely to make a mistake when multiplying out the brackets and with the negative sign. So if we multiply out the brackets, we end up with 16 minus 4x minus 6x plus 9 over 6 equals 4. When you simplify this, you end up with 25 minus 10x over 6 equals 4. Times both sides by 6. 25 minus 10x equals 24. You can do like a double swap here. We have 25 minus 24 is equal to 10x. 1 is equal to 10x. And 1/10 is equal to x. I like fractions, so I'll write 1/10 on the answer line. But you can also write 0.1 if you feel that way inclined. Next. F is trapped inside a square root. The opposite of square rooting is to square. You square both sides, you get m squared equals 1/3 EF. Now, it might be tempting here to divide by 1/3 E, but that's disgusting though, to have a fraction with a fraction in the denominator. So it's better to multiply both sides by 3, and then you get rid of a third very nicely. 3m squared on the left. When you times a third by 3, 3/3 make a whole one. So just get EF. Then finally, divide by E. So 3m squared over E is equal to F. Okay, next question. So the question says, Michael says the lines are perpendicular. Is Michael correct? So let's consider this in two stages, line L1 and line L2. L1 is given to us as the equation of a line. So if I want to work out the gradient of a line, it needs to be in the form y equals mx plus c. So we're going to rearrange this to try and make it look like y equals mx plus c. Now for the next bit, if I want to divide by 2, again, it might be quite tempting to write a big fraction line with the 2 underneath. But what I'm going to do is I'm going to divide both of them by 2 separately so I can clearly see the gradient and not have any confusion here. So the gradient, it's very clear to see, the gradient is -1/2. When you have 2 points, we can use the formula y2 minus y1 over x2 minus x1. So let's label the coordinates x1, y1, x2, y2 and substitute into the formula y2 minus y1 over x2 minus x1. So we end up with 9 minus 7 is 16. 7 minus 1 is 8. 16 over 8 is 2. So the gradient, this one is 2. Are they perpendicular? So what you need to do is if two lines are perpendicular, then this rule holds. M1 times M2 is equal to -1. Times the two gradients together, it should equal -1. So -1/2 times 2, it is indeed equal to -1. Is Michael correct? Yes. Next question. So what we need to do is work out the interquartile range. The first thing that we need to do is write the numbers in order from smallest to largest in ascending order. What I like to do is to write the numbers directly above so that I can see if I've missed out any numbers. So something like this. Okay, I haven't missed any out, that's good. Okay, so how do you work out the interquartile range? Well, there are 11 cricket matches. The median occurs at position n plus 1 over 2. So 11 plus 1 over 2 is 12 over 2, which is 6. The median is the 6th value. 1, 2, 3, 4, 5, 6. So 21 is the median. Now you don't need to work out the median, but if you work out the median, the lower quartile is the middle of the numbers to the left of the median, and the upper quartile is the middle of the numbers to the right of the median. So the middle of the numbers to the left of the median is clearly 6, and the middle of the numbers to the right of the median is 51. So the interquartile range is the upper quartile minus the lower quartile. So 51 take away 6 is 45. Next question. So let's have a look at this. So we have 3 people, Carlos, Flavia, Tazia, and they shared £861 between themselves. The amount of money that Flavia got is 65% of the amount that Carlos got. So let's define Carlos as X. Flavia got 65% of the amount of money Carlos got. 65% of Carlos's amount. So we can either write this as 65 over 100 times Carlos's amount, which is X, or 0.65, which is what I prefer. So 0.65x. Yep. And the amount of money that Tazia got is 22% more than the amount of money that Carlos got. So if you want to increase Carlos's amount by 22%, we times by 1.22. Yep. So Tazia, in terms of x, got 1.22x. Now, between them, they managed to accumulate £861. So let's form a little equation here and add these together. We have 1x plus 0.65x plus 1.22x, and this gives us 2.87x. Oh my god. 2.87x is equal to 861. So I want to work out Carlos's amount, which is in fact x. So I can divide 861 by 2.87. And that gives me 300. Next. So, indices expressed in terms of a or b, or a and b, 3 to the power of 2x. So we know that 3 to the power of 2x is the same as 3 to the power of x in brackets squared. Because what happens when you have a bracket to a power? Well, you times the powers. Well, what's x times 2? It's 2x. So 3 to the power of 2x was formed in this way. Now, inside this bracket, 3 to the power of x is a. So this is the same as a to the power of 2, a squared. Right, the next one, the powers are added together. Well, okay. Well, what do we know about that? How was this formed? It was formed something like this. Because when you times the same base number, you add the powers. What's 3 to the power of x? 3 to the power of x, this is a. But like the first question, we can adapt 3 to the power of 4y and write it like this. 3 to the power of y in brackets to the power of 4. Now 3 to the power of y is b. This is really b to the power of 4. And 3 to the power of x is a. So it's a multiplied by b to the power of 4. The next one, 3 to the power of y minus 1. Well, this is, it's 3 to the power of y multiplied by 3 to the power of minus 1. Now, we know that 3 to the power of y is b. So it's b multiplied by 3 to the power of minus 1. Well, what is 3 to the power of minus 1? Well, the negative means we rewrite it as a fraction, means it's the reciprocal. So 3 to the power of negative 1 means 1 over 3 to the power of 1, which is a third. Now, if you don't know this, of course, you can just type this into the calculator. 3 to the power minus 1 is a third. So this is actually a third b. Okay, so the next question, we've got some equation here to solve. Okay, let's have a go. So we have AB is 2187 and a squared b is this. Now we want to try and work out the value of x and the value of y. This looks like it could be a simultaneous equations or something like that. But it's not quite simultaneous equations because the terms are multiplied together. When they're multiplied together, you're not going to eliminate a and b by adding or subtracting. It's going to be by use of division. So let's write a squared b, which is the higher one, was 177147. I'll write the other one underneath and we'll divide, you see. Let's see if anything happens when we divide. Maybe something will cancel and it will help us work out either a or b and then x and y. Okay, let's have a look at what happens here. Oh, look, a b cancels with a b. Very nice. And a squared divided by a is a. So now I know that a is equal to, if I type this into the calculator, 81. But what is a? A is 3 to the power of x. So 3 to the power of x is equal to 81. Now, if you know your powers of 3, you will know that x is 4. If you don't know your powers of 3, well, just experiment. So you end up with 81. Oh, look, it's 4. So x is 4. Okay, so now I know x is 4. I need to work out b. So a times b is 2187. And I now know that a is 81. So it's 81 times b is equal to 2187. So b is equal to 27. And what is b? B is 3 to the power of y. 3 to the power of y is 27. What power of 3 gives 27? 3. 3 to the power of 3. So there you go. Next. So Barney has a biased coin. When the coin is thrown once, the probability of heads is 0.3. If he throws the coin 4 times, work out the probability it will land on heads exactly 3 times. So it's like this. It's heads 3 times. So it's heads, and he's going to throw it 4 times. So it's heads, 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 and 1 tails. Now, how many combinations are there for this? Well, where could the tails be? It could either be in the first position, second, third, or fourth. So there's 4 positions for tails, so we can times this by 4. So let's work out one of them and then times it by 4. The heads is 0.3, and then again it's 0.3, and again it's 0.3, and then tails is 0.7. Of course, 1 minus 0.3. Okay, that's one combination, the combination that I've stated. Heads, 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 tails. But this can happen 4 different ways, so I can times it by 4 now. When you type this into the calculator, you end up with 0.0756, or the fraction is equivalent as well. Work out the probability that the coin will land on heads at least once. Now, this phrase "at least once" is an interesting one. I'm just going to draw a little tree diagram here just to show you what's going on. So we've got heads, tails. It's 4 times, you see, it's quite a big tree diagram. Heads, tails, that's the second time. Heads, tails, third time. Okay, and then the 4th time, heads, tails, heads, tails, heads, tails. This is why it's not worth drawing a tree diagram. Okay, but I just want you to explore this for a moment and think, heads at least once. What does that phrase mean, heads at least once? Well, it means it could be once or more than once. In fact, every single one of these branches will be valid. The only one that would be invalid is this one at the bottom. This is the only one that does not contain any heads if they're all tails. So instead of working out all of these branches, I could just work out this one and then subtract my answer from 1, because all the other ones, as you know with probability, all of these combinations here will add up to 1. So let's just work out the one that we don't need and then subtract it from 1, and it will give us all the other ones added together. So tails is 0.7. It's 0.7 times 0.7 times 0.7 times 0.7, which is the same as 0.7 to the power of 4. Okay? And then you subtract that from 1, and you end up with 0.7599. Next. Right, so Venn diagrams. Right, let's attempt to fill in the Venn diagram then. So I like to start from the middle and work my way outwards. So we have something like this then. Let's see if we can find the information about the middle. 2 people went swimming, played basketball, and used the gym. So 2 people there in the middle. Okay, they used all 3. 7 people went swimming and used the gym. Went swimming and used the gym. Now, I'm looking for the overlap between the gym circle and the swimming circle, which is this bit I've highlighted in green. This should add up to make 7. As you can see, we have 2 in this section already. So what I need to do is add on another 5, and that will give me 7. So this is good. 5 people played basketball and used the gym. Basketball and gym. So this section is 5 people. There's 2 already there, so there's another 3. 3 people went swimming and played basketball. 3 people went swimming and played basketball. 2 there already, so it's another 1. 27 people used the gym. That's the gym circle, should add up to make 27. So far we have 10. We have another 17. 16 people played basketball. So 16 people in here. There's 6 already in there, so you have another 10. And then 28 people went swimming. So there's 8 people there already. So we have another 20. Now don't forget about the other people who didn't go swimming or play basketball or use the gym. There are 120 people altogether. If you add all of these numbers up in the Venn diagram and subtract it from 120, there's another 62 remaining, and they have to go outside the circle somewhere. So some conditional probability for the next bit. One of the people who went swimming is chosen at random. So what we're doing is we're restricting it to the swimming circle. Okay, so we'll just concentrate on this circle, and we're looking only in this circle. So I know already that it's going to be out of 28 because there's 28 people in the swimming circle. Find the probability that this person also played basketball. So in the swimming circle, how many of them are also in the basketball circle? So if I use a different color, just to highlight where the B circle overlaps with the orange area there. So it's from the B circle overlaps with the orange circle, and you have 3 people there. So there's 3 people who played basketball who are also in the orange bit. So it's 3 over 28. Okay, bounds. Next, so what we do is we first of all create a little table here of our lower bound and upper bound. Now, E has been rounded, or is correct, to 2 significant figures. The second significant figure is in the tenths column. So it goes hundreds, tens, units, and after that it's tenths, and then hundredths, and so on. What you do is you look at the value of the column, half it, and then add and subtract it to get the lower bound and the upper bound. So it's been rounded to significant figures. That's in the tenths column. If you type in a tenth, divide that by 2, and that gives you 0.05. You add this to 4.8 to give the upper band, and you subtract it from 4.8 to give the lower band. That will give you 4.75, 4.85. Okay. So we can do something similar with f. It's been rounded to 2 significant figures. So what we can do is type in the 6 is in the hundredths column. So if we type in 1 over 100, divide that by 2, you end up with 0.005. And all you need to do now is add and subtract this to 0.26 to give the lower band and the upper band. When you do that, you end up with 0.255, 0.265. What we're asked to do is to work out the lower bound of P. P is E times F. How are you going to work out the smallest value of two numbers times together? Well, you're going to use the smaller number for each of them. So we're going to use 4.75 and we're going to use 0.255. When we times them together, we end up with 1.21. Right, now the next part, part B, we can do something similar again. Okay, create the lower and upper band. So when we do that, we end up with 2.725, 2.735, using a similar approach from earlier. And for the other one, it's 0.035, 0.045. And the question is to work out the upper bound for the value of Q. You have a fraction here. What you need to do is think, how are you going to work out the upper bound for a fraction? Do you want a big number divided by a small one, or a small number divided by a big one? And if you want the greatest value of the fraction, you want the highest number in the numerator and the lowest number in the denominator. So 2.735 divided by 0.035, and you end up with 78 when you round it to, well, it's 78.142, etc. But when you round it to two significant figures, it's 78. Okay, so sketch the graph of sine x plus 90. Okay, so it's a bit like this topic, transformations of curves. What does x plus 90 mean when it's inside the bracket? When it's inside the bracket, it does the opposite of what you think, and it moves 90 to the left. Okay, so we're going to move the curve 90 degrees to the left. So all of these points here, I'm just going to choose some nice coordinates here where it's on corners of squares. These ones are really nice. I'm going to shift these 90 degrees to the left. Okay, so 90 degrees to the left. Go there, and so on. Okay, I'll redraw the curve now. Yeah, I shouldn't use that. Okay, let's have a go. Okay, now in the question, it is to sketch the graph for 0 to 360. So I've now shifted the graph 90 degrees to the left, but I need to continue the graph up to 360 degrees. And hopefully you can see the pattern to 360 degrees. If the original graph was continued, the maximum value here would be at 450. So the maximum value here is going to go up to 360 degrees and 1, like this. There you go. I'm drawing a little bit extra actually, but it's fine. The next question says, write down the coordinates of A. So let's have a think about this. Sine x over 2. Well, what does this do? This, so this is the same as sine of a half x plus 3. Okay, let's just analyze this and think about it carefully. When it's inside the bracket, it does the opposite of what you think. So it doesn't half the x values, it actually doubles the x values. So the graph of sine of a half x, well, a normal sine graph looks like this from 0 to 360. So what this means is you get half the graph in the space of one. So you're only going to get, the graph will look like this. Okay, that's the graph of sine of a half x. Okay, and it still has a maximum value at 1. Well, what does the 3 do? Well, the 3 shifts the graph up 3. So the graph will move up 3 units. So at the moment, the maximum point is at 180 because it's right in the middle, 1. Well, what this will do is it will shift the graph up 3. So if the graph moves up 3, it's now to be at 184. Next. Right, sine rule, cosine rule. With questions like this, you always ask yourself the question, do you know a side and its opposite angle? So we have slightly more information on the triangle above, so let's use that one to begin with. Do you know a side and its opposite angle? The answer is yes. So because we do, we're going to use the sine rule. And what can we work out using the sine rule? Well, we can work out dB. dB is connected to the bottom triangle, so we can use that later on. So let's do that first of all. Let's try and work out dB. Now I'm going to use the sine rule, the version that's on the formula sheet, where you have the side on top. So it's x over sine 97 to 9.3 over sine 58. Okay, and if I rearrange this, so you have 9.3 over sine 58 multiplied by sine 97. And you end up with x is 10.88. Now you must not round this here. If you round prematurely, danger of losing the final answer marks. Let's copy down the entire display. Okay, just going to edit the diagram. It's okay, by the way, to write 10.8 here, but use the entire display when working out other sides or angles. So, yep. Now I'm asked to work out the area of this, but I just want to see what other sides I can work out on the bottom triangle. Then I'll deal with the area in a moment. So in the bottom triangle, you ask yourself the question, do you know a side and its opposite angle? And the answer is no. So if the answer is no, well, what are you going to do? You're going to use the cosine rule. So the cosine rule is on the formula sheet, and just copy that down here. It's a squared equals b squared plus c squared minus 2bc cos capital A. Now, if you understand the cosine rule, you will know that b and c are the two sides that sandwich the angle. They sandwich 47. It doesn't matter which one's b or c either side, but they sandwich the angle. So that means the other one is a. So I can work out this side, DC, which is a. I've labelled a. So let's work it out then. I'll leave this as a squared for now. So it's 10.8 squared. Of course, I'm not going to use 10.8. I'm using the display. Plus 11.2 squared minus 2 times 10.8 times 11.2 times cos of the angle that's sandwiched between. Now, it's nice to label it like this because you can see this is set equal to a squared, not a. A will be the square root of all of this. So I'm just going to save a bit of time and type in square root now. So remember, If you press the ands and press equals, it recalls the last display. So we have something like this: square root ands squared plus 11.2 squared minus 2 times ands times 11.2 times cos 47. I've already set it equal in the square root, so this is going to work out A, which is DC on the diagram. So let's just call it DC or A. It's 8.81096 8949. Okay, so I have everything I need now to work out the area of the quadrilateral. So let's focus on the triangle at the top. So it's the area of a triangle when we have angles involved is half AB sine C. Now in this formula, A and B sandwich the angle. So I have two sides, 9.3 and 10.8. Remember, 10.8 is really this. And they sandwich this angle here at D, which I don't know. But of course I can work it out quite easily because angles in a triangle add up to make 180 degrees. So I can work out this by subtracting 97 and 58 from 180. That will give me 25 degrees. So then I can work out the area of the triangle as follows. I'll do a half times 9.3 times 10.8 times the angle that's sandwiched between, which is 25. Yep. Okay. I have to retype this now. So we have something like this: 0.5 times 10.88461,757 times 9.3 times sine 25. Okay, that's 21.39, etc. Let's copy that down. No rounding until you get to the very end. 23.043. And let's do this in another color, the triangle below. So I've got two sides here that sandwich this angle. So again, I can do it again. So it's using half AB sine C. So it's a half times 10.8 times 11.2 times sine 47. So we have 0.5 times 10.88461,757 times 11.2 times sine 47. That gives us 44.578. Let's copy that down. Yep, that's enough. Right, and I can add that to the previous answer, 21.3901774. This gives me a final answer, 65.969. Copy that down as well. 65.969, etc. Okay, give your answer correct to three significant figures. Okay, 66.0. Okay, the 6, which is the 9 round up, so 66.0. Right, next question. This is called completing the square. This is the grade 9 version, where you have 3x squared rather than just a normal x squared. So, like this, what we do is we factorize the first two terms so that we end up with an x squared as the first term in the bracket, like this. 3 brackets x squared minus 4x plus 7. Okay. And remember, the objective is to get an x squared here. That's what you want. Then what you do is you complete the square inside the bracket. I'm going to use square brackets here because I'm going to have curly brackets inside the square brackets. So it just shows that I have different sets of brackets. If I complete the square for x squared minus 4x, what you do is you halve the coefficient of x, so it's x minus 2 all squared, and then you subtract the number in the bracket squared. So 2 squared is 4, so you subtract 4. Now I'm going to draw some lines from the 3 outside the square bracket to the inside of the square bracket, like this. I'm going to times out the bracket like this. So 3 multiplied by x minus 2 squared gives 3 brackets x minus 2 squared. 3 times negative 4 is negative 12. And then when you add 7 at the end, you end up with negative 5. Okay. The line L is a line of symmetry. Using your answer or parté or otherwise, write down the equation of line L. Let's draw a little sketch of the graph so you can see. The turning point is the number in the bracket with the opposite sign and the number on the outside, this bit, what's added or subtracted, with the same sign. So 2 minus 5, so 2 across, 5 down, so it's down here somewhere. I also know that the graph will cross the y-axis at positive 7 when x is equal to 0. So it'll cross up here somewhere. Yep. I can draw a bowl-shaped graph now. So let's try and draw a bowl-shaped graph. That's good enough. Anyway, the line of symmetry is directly down the middle of the parabola. So we know that this coordinate here is 2 across and it's minus 5 down. Now when you have a vertical line of symmetry, or if you want to work out the equation of a vertical line, it's always x equals the number that it goes through on the x-axis. So it's x equals 2. Right, next question. These two lines intersect at points A and B. So where they intersect is where they cross. This is simultaneous equations. What we need to do is first of all make this one y equals. Okay, now that this is equal to y, the other one is equal to y. Because I know y is 6x, I can replace the y with 6x and write it like this. Expand the brackets, so you end up with 6x equals 10x squared plus 10x minus 3x, which gives plus 7x minus 3. And then quadratic must equal 0. So if we subtract 6x from both sides, we end up with 10x squared plus x minus 3. It's up to you how you solve this. You can either use the quadratic formula, or you can use you can factorize it, which is what I'm going to do. So let's factorize this. So a method to factorize a 10x squared, what you do is you write 10x as the first term in both brackets. Now we know that this is wrong because 10x times 10x will result in 100x squared. But don't worry, bear with me a moment. We then times the first number by the last number to give negative 30. We want two numbers here, see, that will multiply to make negative 30. That comes from the first number times the last. But the numbers also add together to make the coefficient of x in the middle, which is 1. So we want numbers that times to make negative 30 add to make positive 1. So if we have 6 and negative 5, then we end up with positive 1 when we add. Right? What you do now is, if either bracket can be simplified in any way, you should simplify it, and the first bracket divides nicely by 2. You divide it by 2. The second bracket divides by 5. If you divide by 5, you get 2x. Divide by 5, you get 1. This is the factorized, completely factorized answer for 10x squared plus 1x minus 3. Now, both brackets are equal to 0. So what we do is we set them separately equal to 0. So 5x plus 3 equals 0, and then 5x equals negative 3. X is equal to negative 3 over 5. Okay, or if you prefer, minus 0.6. The other one, 2x minus 1 equals 0. So 2x equals 1. So then x is equal to a half. Now I can work out the corresponding y coordinates by substituting into either equation. Of course, it's much easier to use this one. Y is equal to 6 times x. So 6 times minus 0.6 or minus 6 is minus 3.6. In fact, should I just convert this into a decimal? Which goes against the couple of. Okay, minus 0.6. So this one is minus 3.6. Let's just keep it consistent. I'll change that one to 0.5. And when I do 6 times 0.5, I end up with 3. So these are the coordinates. Now the question asks, find the coordinates of the midpoint of AB. So how do you work out the midpoint of AB? Well, we need to work out the middle of the x values and the middle of the y values. So let's look at the x values first. How do you work out the middle of minus 0.6 and positive 0.5? So what we do is we add them together. So minus 0.6 add 0.5 divided by 2 gives us minus 0.05. Similar for y's, minus 3.6 add 3 divided by 2 gives us minus 3. Okay, what I can also do is I can also write down that OA is, this is 3 and this is 2. It's 3 to 2. And the other one is also in the ratio 3 to 2. Now that doesn't mean that this is 3 centimeters and this is 2 centimeters, but I know that they're in this ratio. Now, what I want to do now is work out an expression for the area, and I'm going to do that by working out the large sector minus the small sector here, the white one, to end up with the grey bit. So the formula for the area of a sector is pi, this is the big one now, so it's pi r squared times the angle over 360, so 45 over 360. And I'm going to subtract the smaller sector from that. But you see, if I call this length here from O to P r, then I can actually work out what OA is in terms of r. I don't want to call this one r as well, because I've called the big one r. But I know that if you look at the line, it's in this ratio 3 to 2. So 3 parts out of the 5 go from O to A. So that means that OA must be 3/5 of R and AP is 2/5 of R. So I'm going to use 3/5 R as my radius for the sector OAB. So like this, it's pi times my R squared, but R is really 3/5 of R squared times the angle over 360. So 45 over 360. Now this is the big sector minus a small sector, and that gives me the grey bit, which is in fact 81 over 2 pi. Now let's do a bit of simplifying here. Okay, 45 over 360 is an eighth, so you end up with 1/8 pi r squared. Now this bit I'm going to do separately over here. So when I square the bracket, I end up with 9 over 25 r squared. Now if I times 9 over 25 by 1/8 or 45 over 360, then I end up with 9 over 200. So what I've done there is I've typed in 9 over 25 times 45 over 360. You end up with 9 over 200. You've obviously got your pi and you have your r squared as well. This is equal to 81 over 2 pi. Okay. Now, what I can do is I can subtract here because they're like terms, pi r squareds and pi r squareds. So just type in an eighth minus 9 over 200 in the calculator, obviously without the pi r squared. So you end up with 2 over 25 pi r squared is equal to 81 over 2 pi. Both sides have a pi in, so I can divide both sides by pi, and you end up with something like this. Now, I want to try and rearrange to work out what r squared is. Okay, so you have 2 over 25 times r squared equals 81 over 2. Inverse operation of multiplication is division. So if I do 81 over 2 divided by 2 over 25, I now know that r squared is 2025 over 4. And then just to work out what r is, I can square root that. Square root that, you end up with 45 over 2, which is 22.25, but I'll just leave it like that for the time being. The question asks me to work out the perimeter of the shaded region, okay? The perimeter of the shaded region. So what do I know? Well, I know now that r, the distance from O to Q or O to P, is 22.5. I also know that OA is 3/5 of r. So I can work out the radius of OA. So I can do 3/5 of 22.5 or 45 over 2. That gives me 13.5. So this bit here is 13.5, and I can do 22.5 minus 13.5. This bit is 9. So I know that that's 9. Okay, and I also know that this one is 9. They're the same. OQ is the same as OP. So all I need to do now to work out the perimeter of the shaded region is to work out this arc length that goes from A to B and the arc length that goes from P to Q. Okay, let's deal with the arc length that goes from P to Q first of all. So P to Q. So the formula for arc length is 2 pi r times the angle over 360. So we have 2 times pi times r, which is 22.5, times your angle over 360. And then the other arc length is, this is the smaller one now, is 2 times pi times, do we say it was? This is the small radius now. This is the radius of the small sector, sorry. That's 13.5 times the angle over 360. And what we need to do is work out both of them, add them together, and add the other two sides on, which are 2 9s. So add another 9, add another 9. And all of this will give me the complete perimeter of the sector. Now, there's another complication in this question because you don't want to type all of this in the calculator. It says give your answer in terms of pi. So we're going to have to type this maybe individually in the calculator, because sometimes when you type it in all together, it just gives you the answer as a decimal. So we've got 2 times 22.5 times 45 over 360. That gives me 45 over 8 pi. Yeah. And the next one, 2 times 13.5 times 45 over 360. That gives me 27 over 8 pi. Okay. Let's type both of those in the calculator. 27 over 8 plus 45 over 8 That gives me 9. Okay, that's good. So 9 pi altogether, and then plus 18. You can't add these two together because they're different. This is the final answer to the question. Next one. The 10th term of a series is 66. As soon as you see 10th term, you write down a plus 9d. So we know a plus 9d is equal to 66. The formula for this is a plus m minus 1d. The sum of the first 20 terms is 1290. So, sum of the first 20 terms. The formula for the sum of n terms is on the formula sheet, n over 2, square brackets 2a plus n minus 1d. Okay, so we have something like this. N is 20, so it's 20 over 2, square brackets 2a plus, and remember n is 20, so I can write down 20 minus 1, but I know that's 19, so I'm going to write down 19d, and it's all equal to 1290. Okay, now 20 divided by 2 is 10. You can multiply out the bracket by 10, or you can divide the right hand side by 10. That's up to you. I'm going to divide the right hand side by 10 because I don't want too big a numbers to deal with. So I have something like this. One equation here. I have another equation at the top. I can use simultaneous equations to solve for a and d. I'm going to times the top equation by 2. So I have the same number of a's. Let's write that. Times by 2 and I end up with 2a plus 18d equals 132. Okay. Subtract. So the a's cancel. So you end up with d is equal to negative 3. And then substitute this in to work out a. So a plus 9 times 3, so 9 times negative 3 is equal to 66. So we've got a minus 27 is equal to 66. When you solve for a, you end up with 93. A is 93. The question says find the 5th term. As soon as you see 5th term, you write down a plus 4d. So we know that a is 93 plus 4 times negative 3. And you end up with, type that in the calculator, 81. Okay, thank you very much.